Okay, let's look at the last part of Unit 4, which is Chapter 6. So we're going to do 6A, B, and C. Okay, Part A talked about describing distributions. And there's a lot of vocabulary there. And so we need to know what those are. Okay, so the first one is when we look at symmetry. So we are going to need to know what it means to be symmetric, left skewed and right skewed. So we'll need to know what it means visually and in terms of the data. We will also need to be able to use the terms unimodal, which means one hump, bimodal, which means two humps, multimodal, which means more than one, or uniform, where there is no hump. And we did an example where we looked at the heights of families. Okay. All right, now we didn't talk much about this in class, but there are natural maximums and minimums to data, and that is values that prevent the data from spreading to one side. So this can be a cause of skewed data. A typical value is an interval, and we looked at this, and it's going to be a reasonable estimate of the typical. And that's kind of a judgment call. But we looked at this, and this is if you're looking at a histogram where you're not actually calculating the mean or the median, where you're just looking at the data and it's like, okay, well, based on this graph, this would be a typical value. Okay. The mean, we definitely need to know how to calculate the mean. It is the sum divided by the number of values, which is the average. The median is the middle. And I remember mean, and the difference between mean and median is actually one of my students told me this. It's the mean teacher who gives you your average. And the median is that thing in the middle of the highway. So that's the median. We need to know what the mode is. And it's the data value that occurs most frequently. There can be more than one mode or there can be no mode. Now let's also think about the mode in terms of the graph. The mode is your peak because remember this is all frequency. Okay, so this would have, this would be a mode, your mode, your mode, and the highest one is your mode. Here's your mode, your mode. Uniform is, there is no mode. Variation is the spread of the data. Does it go from 0 to 10 or 0 to 1,000? That's the spread. The range goes along with the variation. The range is the maximum minus the minimum value. And that tells you the variation. If you're looking at two sets of data, find the range and that will tell you the variation. So 6A, again, is very much like 5A, and it just gave you a bunch of definitions and where to find them on the graphs, where to find them if you're looking at a set of data. And the last one is an outlier. And an outlier is an extremely large or small data value. It just doesn't fit with the rest of them. It can be an error or it can be just weird data. Now, I am an outlier because I'm a female who is 6'3". You know, the average height of the American female is 5'4". So, you know, if you're looking at a distribution there, I am way out there. And I kind of like it. But okay. All right, so that was 5A. Once again, just a bunch of definitions. Now 5B went into more numeric stuff. It was talking about the measures of variation. And 5A talked about just a qualitative, this is an actual quantitative way of describing variation. For skewed data, we looked at the 5-number summary. Okay. And the 5 numbers are the lowest value, the median, which is the middle between the low and the high. So I start out with the low and the high, find the median of that, and that gives you the median. Then to find the lower quartile, I find the median of the smallest and the median. To find the upper quartile, I find the median between the median and the high value. Okay. Now we can plot this skew distribution with a box plot, or it's also called a box and a whisker. Each of the vertical lines represents one of these 5 values. The smallest value here, the highest value here. The median goes in the middle, then you have the lower quartile and the upper quartile. So between the lower and upper quartile, you will draw a box. This is also called a box and whiskers, because 50% of your data is going to be in here. The other 50% is going to be outside, and we call those whiskers. So you've got 25% here, 25% here. Notice the sizes of these boxes and these whiskers are different, but each represents 25% of the data. If this were symmetric, all of these would be the same size. Okay. All right. Now, if we look at a symmetric distribution, then the center is no longer the median, it is the mean. And then we have a deviation from there, and it is the difference between a data value and the mean. And you learn that rule of thumb about how to figure out what two deviations away from the center should be your smallest value, two deviations away should be your largest, or approximately. Now, to talk about the mean, median, and mode in all of these, let's talk about this in terms of the graphs. Okay, so if it is skewed left, the median is to the left of the mode. Remember, your tallest value, this is your mode. And then your mean is going to be over here. And this is just, we would never ask you to reproduce this. If it's symmetric, the median and the mean and the mode are all in the center. And then this is just flip-flop from here. We know the tallest peak is our mode, so our mode is to the left and our mean is to the right of the median. Okay. All right, so what do you need to know from all this? The biggie is you need to know this. You need to know this 5-number summary, and you need to know how to turn that into a box plot. The symmetric distribution, we do so much more of that in 6C that we're going to look at that separately. Okay, but this is huge. You need to be able to take this value and do that. Okay, then for the normal distribution, this is for symmetric data. You have got your bell-shaped curve here. And I'm going to tell you, I'm going to actually put 2 stars on this one. Okay. You need to know that the mean is in the middle, that you have 1, 2, 3 standard deviations to the right, 1, 2, 3 standard deviations to the left. You do not have to know how to calculate a standard deviation. We will give that to you. Okay, but what you do need to know here is that when you're looking at this graph, and just to save time and space, 50% of the data is to the right of the mean and to the left of the mean. It splits it in half. That's what symmetry is. Between one standard deviation to the left and the right, 68% of your data lies within that. 95% is within 2 standard deviations, and 97.5 is within 3 standard deviations. These figures will not be given to you, so you will need to know that. Okay, so that's huge that you know this, and how to, if you're given the mean, how to find these other values, and then how to find certain percentages of the value. Okay. The z-score, which is the standard score. If you have something that is not exactly 1, 2, or 3 standard deviations, if it's somewhere in between here, this is how you calculate the number of standard deviations. So you need to know that. And for the data value, you need to know when you know the z-score and want to find the following data. If you want to find the value of the data that is 1.7 standard deviations to the right of the mean, then you can do that by, if you have the z-score, which you do, the standard deviation, which you have, and you add that to the mean. Okay. The other thing to remember is that, remember, anything to the left is a negative standard deviation, anything to the right is a positive, because a standard deviation is a measure. So you're adding as you go to the right and subtracting as you go to the left. Okay, so that is just a brief summary of all the vocabulary and the things that you need to know for the Chapter 6 portion of Unit 4. Whoops, I just dropped a pen. Okie doke.